So in this series we are discussing about the data types in the Go language. So actually what is the data type that should be known, right? Let's discuss about what is data type. So data type is that needs to be stored in the form of data in our memory, in the computer memory or server memory, is represent for the particular data that memory holds. Which kind of data is known as a data type? If the memory holds any number or any digit in the memory allocation, that compiler needs to know which data type it is. So in the Go language series we are discussing about the data types, and data types are broadly categorized into the two categories. One by one we are going through the each type of data types and subcategories of the data types. So let's talk about the first broad category of the data type is primitive data types. So primitive data types are known as a built-in data type also. That means the data types are provided by the Golang compiler itself for the programmer to store the value into the memory. So if we want to store any number or any digit into the memory, in the computer memory or in the server memory, while creating a program, so we have one primitive data type inside it that known as an integer for storing that numbers. But in the number system, as we know that we have two different types of number. One is a whole number and one is a decimal number. So integer is not capable to hold the decimal values, but integer is capable to hold any whole number. That means that number should not contain any decimal value. One thing. And also in the Go language compiler we are more consider about the memory allocation also. If we know that what the number range will never exceed then particular range, like 2 की power minus 31 to 2 की power 31 range, then we can go with the int 32. That means the memory allocation is 32 bit inside the memory. The compiler allocate a memory for 32 bit. Also there is if the range that number value exceed that range, then we have a different type of number, that is a 64, int 64. So the memory allocated as a 64 bit for storing that value. Apart from that, right now we have a one disadvantage. In the integer we can't store decimal value, so we required another data type in the primitive that helps us to store decimal values in the memory. For that we have a decimal data type came in the picture. In the data type picture in the Go language we are representing as a float. While we are writing in the program, we are representing as a float 32 or float 64. According to the range of that decimal value lies between that. If we are consider 32 bit range is far capable to hold that data and it will not exceed in the future also, then we go with the float 32. Otherwise we go with the float 64. Most of the time we are not aware about how much, if the user input that value is input or given by the user, then we always go with the float 64, and same in the int 64 as well. For that we not want our program will be crashed in between because of that memory location. But so far we are going through, but we are talking about only a number system. But if we are talking about as a programmer, we also need to store some boolean values. That means we also require to store false or true value in our program at the time of checking the conditions. For that, we came with a new data type, that is bool is represented the boolean value. It only capable to hold only the true and false value. So far we are good with that. We are completed the number system, we are completed the boolean values also, but still something is missing in our compiler data types. Because what is the issue with those data types? We are not able to store any string in so far, or any set of characters. If we want to store any sentence in the memory, or my name in save in any variable, that variable data type should be string or char. But so far we are not good with that. So let's came with a new data type in the Go language known as a string. So set of characters will be stored in this data type we known as a string. String memory allocation is depend on the character itself. Each character holds 1 bit of data, 2 bit of data. One is a null pointer and one is a bit actually. So it holds each character represented into the 2 bits. If it is a 5 character in that string, that means it holds the 10 bits of memory. Now we going forward, the primitive data types are so far good, and we are able to store our numbers, we are able to store our booleans, and we are able to store our string also, or a set of characters. But something is missing. All are the unit, right? Let's consider or move if we want to add multiple value in a single unit or in a single memory allocation. How can we store that? So right now we are not going forward that much, but we can go with the multiple value stored. There is a two disadvantage. One is in a single unit, how can we store a different data types, and second one is how can we store same data type into a memory with multiple memory allocation. Let's consider the second one first. So we came with the new different data type, that is a non-primitive. Non-primitive are those kind of data types that build by using the primitive data type, but it is created or built according to the necessity or requirement of the program. As we consider in the second disadvantage so far in the primitive, we are not able or capable to store any value in the multiple times in a single unit. First thing need to be highlighted here, we are talking about a similar data type in a particular list. So there is a one non-primitive data type came in the picture known as arrays. Arrays represent a same data type for every data. If the list you have all are the numbered system 10, 13, 15, 14, 16, 17, this is the item of the list, then it can be arrays are capable to hold all those numbers into a single variable. We represent as a array. Okay, but array have some disadvantage also. The disadvantage of the array is, one disadvantage, the size of the array is static. We can't extend the size of array after we declaring the size. In between of the program we can't declare the array size again, or we can't extend that array size. That's the one problem. And second problem is it is allocated the memory in a continuous order. So both scenarios are very hectic for the compiler, because the memory allocation, the continuous memory allocation is required more research for that memory in the memory itself. Okay, that memory should be, the memory block should be available for that particular continuous memory allocation. If we consider there is a 10 blocks required to allocate in the continuous order, But so far compiler go with the address 5, but after 3 block there is some data will be stored. So compiler can't store with the 5 address 5 itself. Then it go with the address 10, and we need to go to the memory allocation continuous order. Then 10, 11, 12, 13, 14, 15 until 20 the memory will be allocated to that array, because we need to store 10 data. So far 10 to 19 blocks are hold for this particular array. And the third disadvantage of that, if the size of list is less than the size of array, then it will not shrink the memory, or it will not deallocate the memory as well. It still hold that memory with the default values of the data type. So we have forgot one thing. If the primitive data type, that is all primitive data type have a default value. Integer have a 0, decimal have a 0.0, boolean default value is false, and string default value is black double quotes. That means, so if I created an array of integer, that means if I array of integer that size is 10 and I just put two number in that list, so left 8 block will be initialized by 0 itself. But if you are not allocated anything in arrays and you try to access those data, it will be a garbage value. Once you are initialize the array, then all that array value will be initialized with the default data type, default data value. So far we have good with that. We are some issues will be resolved, but some issues again arise while introducing the array. We are able to store multiple value in a single unit, but that value nature should be a same, or data type should be a same. If I am talking about a string array, then that array will capable to hold only the string value. That array will not capable to hold decimal or integer or boolean value so far. But the size and the memory allocation is an issue for me so far. So they are introducing a new non-primitive data type, that is slice. Slice is nothing but a more flexible and more functionally used for the non-primitive data type. There is a disadvantage in the slice. We need a continuous memory allocation for the array, but in case of slice we are not required continuous memory allocation. All are pointed out differently. Apart from that, there is a one issue. If we have created a 10 size of array and we just stored 3 or 5 numbers in it, then other 5 digits are just wasting the memory. That 5 blocks are nothing but wasting our memory size. Slice will be shrink that much, and if I want stored more than 10 or 20 values after storing 10 digits, so it will extend the size, because it slice doesn't require the continuous memory allocation as well. So far we are good, but array helps us to store only a single data type, but that multiple value. Array and slice help us to store multiple value, but that value data type should be a same. Then we need we require to store, suppose we require to store some data about a student. For one student, how can I store into the array or slice? We can't do that, because that student have a name, have a roll number, have a marks, have a standard like which class he is or she is. So non-primitive data type, user defined data type, have another data type came with known as a structures. So in the structures we are encapsulate, or we are kept different primitive data type into a single unit, and we know it as a structure. Suppose we are still talking about a student have a name. That name is a set of character, so we can say that we need a string data type in that structure. And the student structure, we need to store his percentage. That means that percentage is 49.5, 49.59, or 46, 47, 99.99, something like that. So decimal sounds good for me. So in the student structure, string and decimal value are there, but now the issue is we require the information of the student. So for phone number, we can go with the integer or we can go with the string. We can go with the integer now. So integer is a number, right? Plus, if I added the plus 91 or any country code, then we go with the string, because plus is a character, not a number. So we go with the two string and one float value so far in the student structure. So student structure will be created like that. So how the memory allocated to the structure? Simple, it is the same like memory allocated to the integer, same like a memory allocated to the decimal, but that memory is like string memory is very dynamic according to the characters that have, and decimal has a float 64 value and two string types. So according to all those bits, right, we have that compiler will be calculated that data and put that data into that particular memory allocation, and the compiler will help to allocate that memory to that particular variable. Type is student struct. Okay, now I have a structure. Can I create an array or slice for that structure? With that structure, so I can able to allocate continuous memory allocation or discontinuous memory allocation with the multiple different values as a property of a structure, and same type of array, same type of data type property came with provided by the array and slice. So we kept that, we can do that actually. So array can be created by the array of structure is capable to store continuous memory allocation with multiple values, but each block is represent a particular structure. So far we are not telling that structure is very generic. It is created by me as a student structure. It's created by a programmer as a student structure. So array of student structure is represented a number of students. It is not pointed out only a one student, it's pointed out a list of students or number of students. So we can able to give the marks or store the entire information of a class in a single array of student array. That type is student struct. We are good with that. So far we are good, but every time we are talking about a memory, right? Is it any weight or any kind of data that holds the memory address itself? So yes, we have one non-primitive data type is a pointers. Pointers is nothing but that holds the memory address. It holds the memory address. Pointer is capable to access any memory of the compiler, any memory of your RAM. But if any operations happen on the pointer, it reflected to that data also indirectly. That is the main use and main disadvantage of the pointer. If any operation happen on the pointer, the original location also altered. That's the issue with the pointer. We need more careful when we are working with the pointers actually, because the original state will be lost and original state or original data will be interrupted or corrupted while performing the work, while performing any operation on the pointer itself. So far we are good, right? But as we know, we have a structure. A structure is a are capable to hold different primitive data type into a single unit, or different data type in a single unit. Is any way to store any data, but we are not know actual data type it is. Yes, Golang is provided one another non-primitive data type known as an interface. Interface, if you return type of any function is interface itself, it is representing more generic actually which data type it is: struct, boolean, integer, set of char, anything. So one thing is the use case of the interface is this, and second use case is far better than this, is it is a documentation between the client and the developer itself. What kind of functionalities need to be provided to that client by the developer, and what should be the return type of those functions, that will be documented in the interface. So while the developer start working on the documentation and provide the logic of those functions, then the developer knows what is the function signature look like, how many inputs he got from the client, and what should be the operation return should be, what data type should be written from that function. But the logic and the business logic or any logic written by the developer itself in the interface. So client and the developer are bound to be bound with that documentation. Those functions need to be provided, logic should be provided by the developer to the client. That is a basic most important use of the interface in Go language. But so far we are good, right? Array is the continuous memory allocation, slice is a dynamic memory allocation, is any data type that use key value pair so far. So I can use any key and store a value corresponding to that key. Oh, so far we don't have any data type, right? Okay, let's check the data type. Can we have? Yes, we have that data type, non-primitive data type, that is known as a map. Map is nothing but a key value pair in a Go language. So what is map? I said it is a key value pair. Okay, so value can be anything. Yeah, value can be anything. It can be an integer, it can be a struct, it can be an array, it can be a map itself, it can be an interface or pointer, anything. So you know that if there is a roll number 1 associated with the student 1, we have a student structure. So I want, according to their roll number, those student variables should be associated. If I enter 1 in any map, the student 1 information should be provided. If I give the 2, then student 2 information should be provided. That kind of logic or that kind of storage required. So for that kind of storage we have a map. Okay, and the map is memory allocated on the heap, not in the stack. So going forward, we have a chan keyword. Okay, what is the data type? It sounds different from other programming language. Yes, it is, because chan keyword is used for the Go channels. We are not able to define chan because it is complex, because in which we are talking about a Go routines between the our compiler execute the program on the CPU core. If core 1, we have a quad core, and our program is working on a core 1. So in the core 1, if we have a 4 different operation need to be performed, so we have created a go routines, but which go routine is completed and which go routine is not completed yet, we can using the chan full form is channel, using that channel keyword, chan keyword, we can transmit the data between the go routines, and we can provide that my operation is completed to the main function. Other so far each function alter the chan, update the channel itself. Each channel provides the feedback to the main function. If the channel provides the feedback that execution is completed, then our main go routine function also can be stop execution also, if they don't have any set of instructions so far. So we are using the go routines, we are promoting the parallel programming actually. Going forward in the advanced Go language series, we are learning the channel also. As per the discussion regarding the data types in the Go language, let's do practically how we implement the data types in the Go language and how we created the variable of our different data types. Let's start. So first we need to create a package in the main package. That should be a main package. I have already created a one file name is a datatype.go, and now I need to import one statement, that is fmt statement, for the printing perspective. Apart from that, need a one function name is a main function, and okay, so we need to declare a number of variable declaration and definition, right? So let's create a one variable with the integer int32 type. So there is a no int type in the Go language, so we go to the int32 or int64. So let's giving the integers 32 bit, that's int32. And so why it is int32, right? So it's a differentiate between the int32 and int64, as we discussed theoretically. int64 is a very big range of the value stored in the int64. So 64 value can be initialized in the integer 64, but in int62, if you try to initialize the value of int62 in the int64, it's perfectly work fine. But if the value is int64 value assigned to the int34, then it's giving the error. So these are the two data types of the integer. Let's close the explorer now. Okay, so let's assign the value of integer 32 and int64 is the value of int32 is 2 ki power 31 is a maximum limit, and minimum limit is 2 ki power minus 31. That is value, the int32 value lies between this range, so you can assign any value. So far let's save this value, right? And integer 64 value is at something big. Okay, so this is the two data types I create, that where integer 32 is nothing but a variable name. I can define anything according to the standard of the variable definition. It should be start with the letter or start with the number, but it cannot be start with the underscore. That's the one thing. Another thing is, now there is a primitive data type, right? We are talking about the primitive data type. So that integer is completed int32 and int64. Let's print those values. Integer 32 is printed, fmt.println. Integer 64 is also printed now, right? And the semicolon is optional. If you put the semicolon, then it's good for us. If you not put the semicolon, then it's fine for that. Now we need to run. So using the command, we can run that program. Go run, and the file name data types datatypes.go. See, both values printed, but we are not differentiated that what is an integer value and what is an int value, right? So if I want to change this to the printf, I am more used to for the printf function, percentage t integer 32, okay, and then followed by percentage t. I just want to label it, give that the value of the int 32. That's why I write int 32. And now it's a 64. I convert it to the 64. So percentage t is used for giving the type of the object or type of the variable. Now again we need to run the command go run datatypes.go. If you see, it shows int 32 as a type. There's a type of integer 32 is a int 32, but why it is not working the integer? Give me a second. It's work, but it's not printed in a different line. It's concat the two lines actually. Let's clear our screen and go run. Now it's perfectly work fine, right? But still we have figured it out that our command prompt is dollar symbol is within that our output. So let's fix that also. Now it's working fine. 32 value type is a 32 and the value it is, and the int 64 is a label. This int 64 shows the type by the percentage t, and this is the number, that value we have initialized in the int 64. That's the one thing. Okay, and another thing is now second primitive data type is float. So float having also 32 and 64. Float 32 where float 64. We can't work with that way like I write, so because it's a keywords, then I write like this, so it looks different, right? If I write float 32, I can initialize the value 2 की power minus 31 to 2 की power 31. That's the range of the float decimal value. It helps to hold the decimal values. So there is a two part of the number. One is an imaginary number, one is a whole number. I can initialize with this value, and float 64 is something like this. So it can be hold that much value. fmt again I need to run this, but instead of int 62 I use float 32. Instead of d, right, I can use f. That's a format specifier for the float, and float 32 goes with the float 32. So 2 times it's checking and they print a different thing. Awesome, right? Let's check the output. Undefined float 32s. There is something s came, right, because I tried to save it. That's why go run data types.go. Float 64 declared and not used, because that float 64 is so far we are not printed. We are declared, we have defined, but we are not used that. So let's use them also. Print the value of 64 as well. I just try to showcase the errors also. If you are not using any variable in the Go language and you are initialized and kept that value, right, then it's also giving the error at the compile time. Your program will not run. See, there's a float 32, it's perfectly shows something, right? But hey, I lose some value, right? Why? Because that value is too much. 2, 3, 9, 4, something. If I decrease the value, right, it working fine, I guess. Let's check it. And if you see, right, 3, 2, 4, 8, 4, 4. But what I assign is 4390. So it's automatically round off because that's the value is too much. If we need accurate values, then we go with the math package. We will discuss later on. Now it's working fine, right? 238, 2399996. So it's giving a 6 values after that, right? How many decimal need to be printed? You can assign with the format specifier, right? Apart from it, it's working fine for us, right? So far, right? Now the third primitive data type is a boolean. So where booleans bool. So what is the use of boolean actually? So boolean is used for to run only the two value. Boolean handle only two values. One is a true or second one is a false. By default, it is initialized with the false value, as we know, and after that we can assign the boolean value to the true if it is used for some conditions or some flags. So we can know that flag is up. If that flag, right, that boolean value is true, then we can perform any simpler task according to that. That's why we are using the boolean value. I just try with the binary. We represent the binary actually. I'm not sure about the format specifier for the boolean. Yep, not B is a bool, right? And bool equal to true. It shows bool equal to true. So let's change it into the capital B. I guess it's working fine for me. Go run. Data types. Go. No, it's not working. But somehow if I use D, right? So maybe. Sure about the format specifier of the boolean because we are using for the conditions, not for the printing perspective. So but it's the data type, it shows bool and the value is also true. Hope you understood. Alright, now we need to change it to go with the another data type. What is it? So boolean is done, right? Boolean is done. Now the another data type is a string. So string is nothing but a array of characters. Strings. Okay, give me a second. Okay. CHR strings, right? String. So by default it is initialized with the null value, double quotes only. No any character will be part of it. So we need to assign some value like bits bytes as or our channel name. So let's print it also. And the value should be in a double quotes, not in a single quote. That's a label I print. Using that I use this. clean our dash, we clean our terminal because so many inputs and outputs we shown in the types. See, it shows character sets over here, right? The type is a string and the bytes is the value. Hope it's working fine, right? So far we are aware about the boolean, float, char and the integers also. Those are nothing but a primitive data type. Okay, now we are create a new function. Okay, we are create a new function, that is a function main again with the non-primitive data type. The first non-primitive data type we discussed as much as now, that is the array. Array is nothing but a homogeneous in nature. That means it holds the one value, multiple values, but those values nature or behavior is the same. So for that we can create the array. I name the array name is ARR of size 10 of integer and 32. So ARR, I just initialize the one value 102 and give me a second. So array type and the percentage plus v, that is used for printing any interface. That's a different thing. I will tell you later on why I print interface instead of array. Yeah, okay. If you see, it shows array that size is 10 and 32 data type, and only the first index, right? First index value is 102 that we have initialized in the line number 7. Apart from that, all value is initialized with the default value, that is 0. One thing, right? Now we are discussed about the slice. So we have an array, right? So slice we can take from the array itself, ARR 0 colon 5, right? So it is a dynamic slice will be came with for us. Let me copy this, paste it. Slice is nothing but a dynamic array, as we know. In data type, see what is the difference between that is in this type, right? In the line number 8 it shows only the 10 size, but in line number okay, that is a slice actually. So but in line number 11 it shows no limit, it shows blank array only. So that means it is a dynamic. If I want to add, okay, we have a 7th position, suppose on 7th position just give 100. It's work fine or not? Let's check. Go run data types .go. It's not working fine, right? Because we are not appending, we are not using any function, we are directly assign the value. That's how slice is not work, because suddenly we have doing that, right? If I do append slice and then 120, now the thing will be changed. Go run data types.go. Now it's working fine, right? This is the first 5 value, and last append the 120 value is its append also. So it is dynamic in nature, that length is not fixed. That's the difference between array and slice. Now we move on the next data type, that is the map string and type. So for that we create a map data, that is my variable name, and creation the map, right? There is a keyword we use, map. The key value data type may be a primitive or non non-primitive, but it should be a primitive data type. So int, and then there is a any kind of data. So int, suppose I initialize with this, right? Then how can I initialize map data now? What value holds, like the value of 1 holds 2. Okay, let's take the line number 11, copy the line number 11 for us and paste over here and change with the map. Okay, need to clean our terminal. Clear, go run data types, start go. It's giving some error, right? Assignment to entry is nil map. Why it is giving error? Because it should tell me that data, that value you have assigned in the line number 14, that value is not initialized. So first we need to initialize it. Okay, so how we initialize that? Now again map int, map int 1, 2. Comma is missing because every time we need to provide the comma, line number 14 itself. So it's giving all the errors if you miss something. Okay, now it's working fine, right? So we have created a map, type is int, and the value of right now we hold is 1:2. That always shows in the map format. If I add something over here, 2, 3, so and initialize it, it's a dynamic in nature, so any value, how length of that value will be n. It's not according to the size of the memory. Now it's take two values, right? 1:2 and 2:3. That's the map. Okay, now we are talking about the user defined data type. User defined data type is the most common data type we use for solving our problems, because client data is always a random data. We need to structure that data in our own way, so we are using that. For that we are using the struct. So user data, that is the struct name I'm giving, and I just take 2 or 3 as we know, as we take the example of the student, right? I remember the student, we have take one value that is a percentage or showcase the marks. So where percentage as a float 64, where phone number we can take in 64, and the name is string type because it's a set of characters. So that's the data type we have created. That is a non-primitive data type actually. Now we need to create a variable of this data type. So as I create a mark as a variable name of the student data type, so simply we have created that. Now we need to add the data in the mark to student. So the name of the student is mark itself. Then the phone number of mark is something like this, and the percentage, right? Percentage without symbol I added 98.9, but if you see I use mark every time, mark dot percentage, mark dot name, mark dot phone number. That's how we are initializing the single user defined data type. So we telling the compiler in the mark data type we have a name, we have a phone, and we have a percentage. One by one we have initialized all those values and telling the compiler to save the data into the memory itself. That's the one thing. Okay, so give me a second. User define data type, we write mark. Now we clear that. Go run data types dot go. Syntax error. No declaration statement outside of the function body. Line number 20. If you see, why we are missing this? So many errors, right? It is not a variable. We are not defining the variable actually. We are defining the data elements. Just remove those data types. Comma over here. Data types. Now it's working fine, right? What is the error before that? We have not creating a variable, we have just creating elements of in the structure itself. Now if you see, there is a user defined data type as a label, it's printed. Type is a main dot student. Okay, that is a type of the variable, mark variable. And what is the value? Mark hold is percentage is the 98.9, phone number is this, and the mark is name of the student is mark. Now we have know how to create a user defined data type. So as we know, we can able to create an array of the students also, because in the class we have multiple students in a one single class, like 36 students in a class. So we can create an array of the 36 student. I just show the syntax, I will not initialize any value or something. And so students, I created the students, that's a plural, and suppose 40 students in a class, right? So I just want to create that variable name with the size of 40 student. So it will be have a text value with the 40 length of 40. This is the way we have created the array of the students. And now in the, like, we have two things is left, one is the interface and one is the chain, right? For that we have discussed in Golang series, because that thing is little bit complicated, like type interface faces interface. That's the way we can define the interface. And chain is the primary keyword, like int chain, right? abc chain, right? That is also keyword chain. But how we use chain and interface in the going on series, we can learn about those things. Thank you for watching this video, and I hope you learn you're familiar with the data types after this video. Thank you very much.